All right, hello everybody. I am very sorry I am not here today. I had every intention, but full disclosure, unfortunately, my fiance ended up getting COVID, so I am waiting for a test result to know that I am in fact safe to come back. And so hopefully it's just for today that I'm out. That being said, we'll see what happens as the week goes on. So you should be in your seats and settled. For this do now, you're going to have 5 minutes. Go ahead, work through these questions silent and solo. You can pause the video here. All right, so taking a look at these now, number 1 should look familiar, right? We've done quite a few of these at this point. The first thing we need to remember when we're looking at this is I need this set to 0, right? This isn't in standard form right now, but I can get it there. I can get it there really easily. And so in order to do that, I'm just going to add 12 to both sides. And so I'm going to end up with x squared minus 7x plus 12 equals 0. And now we ask ourselves our ever so important, lovely question, is this factorable? Well, let's take a look. Let's take a look at our factors of 12. We have 1 and 12, 2 and 6, and 3 and 4. Now, we are looking for 2 of these factors to add to be 7. Well, luckily, hey, look at this. 3 and 4 will. And I know that because this sign here is positive and that this one is negative, they both need to have negative signs. So I know this factors really nicely. And so I'm going to end up having x minus 3 times x minus 4. Apologies, my computer is not liking when I write 4s lately. X minus 4. Again, still equal to 0. And remember, we're looking for the solutions here, right? And so I know that if I have x minus 3 and x minus 4, what I really have is x is equal to 3, and that x is equal to 4. And these are my 2 solutions. Now, let's look at 2 and 3, because really what we're going to be doing today is a combination of 2 and 1, or even 3 and 1, right? Now, for these, it goes back to a skill that we haven't actually used in a long time. But when I see something like x over 4 is equal to 8 over 3, I want my brain to immediately start to go, oh, I have 2 fractions set equal to each other. I can cross multiply, right? So we remember this annotation, and we remember that we make this annotation, right, these 2 sets of circles, because the way that this is going to work is I'm going to multiply my 3 by this x, right? Anything in a circle, we multiply together. And so on my left, I'm going to have 3x, and it's going to be equal to, well, then my other circle. I'm going to multiply 4 times 8. 4 times 8, well, it's going to be 32. From here, I solve it just like I normally would. Divide both sides by 3, and x is going to be equal to 32 over 3. Awesome. Well, that was a bit of a basic example, right? And so let's take a look at something a little bit more closely related to what we've been doing, right? So in number 3, again, we're still being asked to find the values, or the possible values of m, right? And so I'm going to do the same thing. I'm still going to cross multiply. On my left, I'm going to have m times m is equal, well, 2 times 32, that's 64. And so on the left, that m times m, right, that's something we've done before. It's something we know. That's just going to end up being m squared equal to 64. Now, at this point, though, let's think, how do we undo a square? Well, we take the square root of it, right? We take the square root of both sides here. And so on my left, I'm going to have m, and I'm going to have equals. Now, we have to remember, we absolutely have to remember that when I'm taking the square root of something squared like this, I have to account for the fact that the negative is going to be an option. And so my answer is going to be plus or minus 8. If you selected option B, you have got to account for that negative sign. All right, so there will be no formal notes today, and so because of that, go ahead and turn the page. You should have in front of you a page that looks like this. It's Explore at the top, and it looks similar to one of the problems we just worked on. I'm going to work through this first one with you, or well, in front of you, and then it's going to be your job to work on the second one. So let's take a look. Now, I again have two fractions set equal to each other, and so my brain is still going to go, I want to cross multiply. And so we're going to do that same thing, right? I have x times x plus 5, and I'm going to have 6 times 6. So on my left, 36, right, 6 times 6, is equal to x times x plus 5. Now, it's super important that we add in these parentheses right here. Without it, if we are trying to skip steps, I do not want to see x squared plus 5. This is wrong. This is not what we want. So I need to put in these parentheses because I need to remember that I have to distribute these. I have got to distribute the x into both of these terms. And so I'm going to have 36 is equal to x squared plus 5x. Well, hey, this looks suspiciously like number 1 in our do now, right? This looks like something that could be in standard form, but it's not there yet. So let's get it there. We're going to subtract 36 from both sides. It's going to give me 0 is equal to x squared plus 5x minus 36. Well, awesome. Again, we ask ourselves the ever so important question, is it factorable? So we're going to look at the factors of 36. I have 36 and 1, 23 and 2, 18 and 2. Wow, I don't know where that came from. Apologies. 18 and 2. Hopefully you yelled at me through the screen. 12 and 3. And 9 and 4. Now, this negative sign here, right? This negative 36. This is going to tell me that these signs have to be different. And when I look at this b value, it's positive, which means that the larger factor has to be positive. So I know that all of these are positive and all of these are negative. Well, let's take a look. Do any of these pairs add up to 5? 36 minus 1, not going to get us there. 18 minus 2, not going to get us there. 12 minus 3, still not going to get us there, but we're definitely getting closer. And then 9 minus 4, well, hey, look at that. That's a positive 5. So I'm going to have 0 is equal to x plus 9 times x minus 4. Which means that my solutions are x equals negative 9 and x equals a positive 4. Remember, anytime we go from factor to solution like this, we always want to make sure that we are switching our sign. So we have x equals negative 9 and x equals positive 4. Now, you are going to follow that same set of steps. Again, I'm going to tell you right now, parentheses are going to be your friend here, and you will have to either double distribute, window method or area method, or use FOIL on this next one. But for now, go ahead and give it a shot. You're going to end up having, let's see, take 3 minutes. 3 minutes, silent and solo on example 2. Go ahead and begin. You can pause the video here. All right, so you should hopefully have worked through example 2 by now. It is still cross multiplication, right? We're still using that same strategies up above. I'm making my annotation. I'm being very deliberate. You're just going to see my mouse move quite a bit to make sure that I'm being clear on exactly what pairs I'm circling, right? I have 8 times 5, and then I'm going to have x plus 3 times x plus 9. Now, again, parentheses are our friend here. So, on the left, x plus 3 times x plus 9 is equal to 5 times 8. Well, that's 40. Awesome. From here, this is why I said you can either double distribute, you can use your area or window method, or you can use FOIL. Use whatever method you are comfortable with. I like FOIL, and so I'm going to quickly draw in my FOIL annotations, right? First, inner, outer, last. There we go. And so I know that I'm going to have on my left x squared plus 9x plus 3x plus 27 is equal to 40. Awesome. Now, before I do anything, I'm going to combine my like terms on my left-hand side, and I'm just going to clean this up a bit so I can actually see fully what I'm looking at here. X squared plus 12x plus 27 is equal to 40. From here, remember, we always want to set quadratics to 0, and so I'm going to subtract 40 from both sides, and I'm going to end up with x squared plus 12x minus 13 equals 0. All right, awesome. Well, once again, we asked the ever so important question, is it factorable? I'm never going to let you forget it. So it is, and in fact, we're going to have x plus 13 times x minus 1 as our factors here, still set equal to 0. And that means that our solutions are going to be x equals negative 13 and x equals a positive 1. All right, if you need, take about 30 seconds, make sure you have this down, because this is going to be the bulk of what we're practicing today. All right, so let's scroll down. Let's take a look at problem set A, right? In problem set A, I want you to work on, let's do problems 1 and 2. You're going to have 5 minutes, and feel free to work with a partner on these two. Go ahead and get started. You can pause the video here. All right, so hopefully you and your partner were able to work through both of these. Now, on number 1, pretty straightforward, right? Again, we have two fractions equal to each other. We want our brains to immediately go to cross multiplication. And so I'm going to make my annotations, and then I'm just going to start to solve. I'm going to have m times m plus 2 on my left equal, well, 5 times 3 to 15. I'm going to distribute this m in. Again, parentheses are our friends in these. And so I'm going to have m squared plus 2m equals 15. Again, this looks like something that could be in standard form, but it's not there yet. So let's get it there. I'm going to subtract 15 from both sides, and I'm going to have m squared plus 2m minus 15 is equal to 0. Perfect. We have a standard form equation, and we have it already set equal to 0. From here, again, that magical question that we are never going to be able to forget. Is it factorable? Let's take a look. 15, it's only got two pairs, right? It's got 1 and 15, and then it's got 3 and 5. Let's take a look. 15 is negative, which means the signs have to be different, right? Because it's the only way to get a negative when we multiply. And the b value is positive, which means that the larger value is going to be positive here. Well, let's take a look. Negative 1 plus 15, that's 14. That's not what we want. Negative 3 plus 5, well, that's positive 2. Perfect. That's exactly what we want. And so right away, I know that I can factor this, and I'm going to have m minus 3 times m plus 5 is equal to 0. And then from here, I know that m equals positive 3 and m equals negative 5. And remember, we get these values from simply taking this factor, right? If I bring this down here, I take this factor and I'm actually just setting it to 0, right? m minus 3 equals 0. When I add 3 to both sides, I know for a fact that m is equal to 3, right? And I would do that for both of those. Remember, that comes from that lovely zero product property, something that is super awesome and super important because it tells us that if these two things being multiplied together equal 0, well, either one or both of these have to be 0. So we use that, and we know for a fact that m is going to be equal to 3, and m is going to be equal to negative 5. Now, looking at number 2, if you looked at this and went, well, hang on a second, there's only one fraction, we want to remind ourselves here that we can always write whole numbers as fractions, right? It's just that their denominator is going to be 1. And so I'm going to have 4 plus x squared over 10 equal to 2 over 1, because now I can cross multiply. Look at that. And so I'm going to have 4 plus x squared, right? I multiplied by 1, so nothing's going to change there, is equal, well, 2 times 10, that's 20. Now, what sets this problem apart from the last problem is, let's take a look, right? I'm going to try and highlight this step right here and this right here. Now, I'm going to do something different, and then I'm going to kind of wrap back on why I didn't follow the same steps as number 1, right? Because from here, I'm actually just going to subtract 4 from both sides. And when I do that, I'm going to have x squared is equal to 16. Well, as we talked about previously, the best way to undo a square root, the best way to undo a square is a square root. And when I take that square root, I'm going to have x equals positive or negative. Remember, we have to keep that with us, 4. Now, if you're going, well, wait a second, why did we change how we were working on these? It's something that I wanted to see is over here, but isn't here, right? This right here, this 2m, right? What essentially became our b term or our b value isn't here. It's missing on this side. We only have an x squared and a constant. We only have an a and a c. And because of that, it's actually going to be easier and far faster for us to just move everything else to one side and then take the square root. Even if this wasn't a perfect square, it's still going to be faster because we know how to reduce that radical, right? I don't have to worry about factoring. I don't have to worry about doing any of that. I simply move it to one side, take that square root, and look at that. X is equal to positive or negative 4. All right, now I want you to actually we're going to go take a look at problem set B. And in problem set B, I want us to pay really close attention to number 1, right? In fact, this is going to be the only one we're going to work on. You do have to do both parts of it, right? Part 1 and part 2. But I want us to work on number 1 because I want us to be really deliberate with our annotations, and I want you to really see exactly why we're putting in that annotation. For this one problem, you are going to have 4 minutes. You got to work on it silent and solo. Go ahead and begin. You can pause the video here. All right, so hopefully you are able to get through that. Again, this is going to be a case of cross multiplication, and so the first thing I'm going to do is I'm going to make this annotation. And the reason I want to make this annotation, the reason I wanted us to zoom in on this question is because it really actually asks us which of the following correctly displays the first step in solving the equation below. Well, that first step always comes from our annotation, right? This annotation is so that we know exactly what's being multiplied. And so I know that, hey, in one circle here, I have x minus 2 times x minus 6. And so I'm going to come down here, and I'm just going to go ahead and write down this first step. I have x minus 2 times x minus 6. And that's equal to, well, I have negative 4 times 2. So negative 4 negative 4, there we go, times 2. Now it's a matter of, okay, well, which one looks like this? Well, I have x minus 2 times x minus 6. Well, it's not that one. It looks like it's going to be B, but let's double check. No, definitely not C. No, definitely not D. And so it is, in fact, B, right? That's our first step. We did it. We showed it right here. And so now, part 2, solve, I'm going to jump in right from this first step. Again, use whatever method you want for multiplying 2 binomials. We have a few different ways to do this now. Again, I like FOILs. That's what I'm going to use. I'm going to take this. I'm going to make my lovely annotations because as we just saw, annotations are important. It's how we make sure we are doing the correct thing. And so I'm going to have on my left x squared minus 6x minus 2x plus 12 is equal to, well, negative 4 times 2, negative 8. From there, we're going to have, if we combine our like terms, x squared minus 8x plus 12 equals negative 8. From here, I want to add 8 to both sides. And I'm going to get x squared minus 8x plus 20 equals 0. Now, again, that lovely question, is it factorable? Let's take a look. 20 and 1, 10 and 2, 5 and 4. That's a 4. Again, I apologize. My computer apparently really likes turning 4s into 9s. 4. There we go. So, I know for a fact that this 20 is positive, which means that our signs have to be the same, and my b value is negative, which means that all of these signs have to be negative, right? It's the only way the multiplication will work. Now let's take a look. Negative 20 plus a negative 1? Nope. Negative 10 minus 2? Well, that looks like it could work, but remember, that's actually going to be negative 12, so that won't work either. And I have negative 4, or negative 5 rather, and negative 4. Well, it's going to be negative 9. So this, in fact, isn't factorable. So then it brings us to our second question. It's one we ask ourselves far less recently, but our second question we need to remember, well, is our b value positive? Well, we have negative 8, or sorry, is our b value even? Not positive, even. We have negative 8, because yes, that's even. That means that we should complete the square, right? We don't want to jump to quadratic formula because it's going to be more work than we have to actually do. So I'm going to complete the square. In order to do that, I'm going to move my 20 back to the side. I'm going to have x squared minus 8x equals negative 20. From here, remember, I am trying to create a perfect square trinomial on my left-hand side, hence the name, complete the square. And so in order to do that, I'm going to have my b value. So half of negative 8 is negative 4. And then I'm going to square it, 16. Awesome. I'm going to add 16 to both sides here. If you heard that and you're going, what on earth is he talking about? Remember, look back in your notes. When we talked about completing a perfect square, we had that lovely note of PST, right? And then we talked about how our C value was going to be B over 2 all squared. If we aren't sure, make sure that we can find that in our notes. And so from here, I'm going to have x squared minus 8x plus 16 equals negative 4. Now, I'm going to bring this up here because I did not give myself enough room. So I'm going to go ahead and I'm going to factor this. We made a perfect square trinomial for a reason. I want to factor it as such. So I am going to have x minus 4 all squared is equal to negative 4. From here, normally I would take the square root of both sides, right? I need to get rid of that square. But on our right-hand side, we run into a really big whoopsie, right? We have a negative sign underneath our radical. And as we've talked before, for the purposes of now, that sort of breaks the radical. And so we saw, when we talked about our discriminant, what this is going to lead to. But we should know and hopefully recognize that as soon as we see this negative radicand right here, that we're actually going to have no solution, right? This isn't ever going to actually have a value that works. If we think about this in the quadratic form that it's in, think of something that's never going to hit that x-axis, right? And so this actually has no solution. All right, go ahead and pause if you need. Get this down. I want to make sure that you do, in fact, have this. All right, and now we're going to jump to our exit ticket. So we're going to scroll down. And before we fully jump into our exit ticket, I will say, even though I'm not there, I did print off study guides for you. Hopefully whoever is filling in can either pass them out or they can be put by the packets when you walked in. But remember, that study guide is going to be worth extra credit if you have it filled in and completed on Thursday when you take your test. Remember, you have a test on Thursday. And so you're going to have until the end of class to work on this exit ticket. It's only 2 questions. I don't think it'll be too bad. You've got this, and I'm hoping I see you soon.